Hello, everyone. Very happy to be there with you today. My name is Philippe.
Hello, my name is Thibault.
And we'd like to introduce our new software, which is called Crowdbased. It's also about data privacy somehow, and I think it nicely connects with the previous presentation. So without further ado, let's dive into it. So, yep. So you see, we are security professionals with Thibault for like 1 or 2 decades already, and we have tried to analyze what happened to those people that get hacked, and even the biggest company get hacked. Like those logos, you know them all, and they got hacked big time. They lost records, they lost money, they lost pretty much anything you want, and they have one thing in common: they have close to unlimited budgets, and they have vast teams, they have SecOps, DevOps, they have like appliances, licenses, they have like compliances every year, penetration testing, whatever you want, they have it, right? If they don't have it, then nobody has. I mean, we cannot expect JPMorgan to be missing on budget or something like this. So nevertheless, it got hacked. So what's wrong? I mean, even the best team in the world could be defeated. Proof it's not just a problem of mean. Actually, they are facing a problem that nobody really can solve. So the problem is about time. Say you have an application and it's got a vulnerability, you will have to wait for the patch, right? And then when the patch is out, you will have to wait for it to be deployed on your machine. So between the moment where the vulnerability is at large and the moment where you are patched against it, it could take like weeks. So time is always on the side of the intruder, And then there are the unfiltered access. Unfiltered access are everything that is just going through your firewall without any further check. For example, like mail, DNS, applications, web connections, and so on. They are just not filtered. You cannot say, I just want to accept those IPs and not those IPs. So basically, most of what's at risk is just not filtered. It's great. I mean, the firewall is basically a teapot boiler, right? And then the parameters. The parameter is a big question nowadays. I mean, with Shadow IT, Cloud, SaaS, and the crisis that struck us, people are connecting with VPNs from home, for example, and they are bringing all the zoo they have home, like their home appliances, their PlayStation, their Android devices, and all, at work, more or less. So yeah, there are things you can do, but most of the companies just don't know how to do it. And so there is no more perimeter as such, and they're all interconnected. And last but not least, the money. There's a money issue here because the resources that the hacker is involving is something like his time, stolen servers, and a bit of open source tools, right? So it doesn't cost him much, if anything at all. Whereas you are defending with your money, with SecOps teams, with a lot of licenses and things like this. So it's quite critical that you can assess the ratio. It's like 1 to 1,000. You invest 1,000 and they're investing $1 in attacking you. So more about this perimeter thing. There is no more castle strategy, right? Back in the 80s, you could like put everything in the same place, put a big wall around it and call it a day, right? You could say everything is inside the castle, is protected. That's super. I'm super happy. But nowadays, every device, every asset has to defend himself alone. So what we want to do is teach them Aikido somehow. And what we thought with Thibault is like, what is the universal language across all the generation of devices, right? Even for the ones that are 40 years old, up to the most recent bleeding edge one, like your 5G phone or watch. They all have one point in common: HTTP. This is sole and only point across 40 years of IT industry, right? So we know that if we want to have a universal solution, it has to leverage HTTP somehow. So we thought, okay, let's go with this constraint, go to the paperboard and start drafting something that could help people, right? And we decided that IP reputation needed a second go, a second look on it, because it was a success partially, if you ask me. For example, Spam House has been a success, right? It's blocking spam, and it's pretty efficient at it. Even though people are complaining that they have to deband themselves and that the process are long and RBL are pain in the ass and so on, but mostly it worked. But the other one, they didn't work much. Why? Because it's always outdated. It's always 2 or 3 months old signature you get inside. So not signature, but IPs, I mean, you get inside. So it's not really relevant, right? Because the IPs are rotating on a daily basis, if not an hourly basis sometimes. If you rent servers from Amazon, you're going to get the IP that was used by someone hours ago sometimes. So we needed something else. We need to do a crowd reputation system, a crowd-based reputation system that would be so wide and so large that it could be real time nearly, that if anything would happen, we could update in real-time signatures. So we were up to a new system and we decided to give it a go. What do you think, Thibault?
So yes, the idea behind crowd security is not, if you take apart the fact of sharing information, is not so innovative. We are reusing concepts that have been seen and implemented successfully by solutions such as Filterband. So here's the idea that you can collect some data. It can be, for example, log files, but it can be, moreover, any kind of stream of information. So it can be, for example, if you are using AWS, it can be CloudTrail and so on. These logs, they will be normalized and enriched. When we speak about enrichment, it can be things as simple as geolocalization information, for example, because it might help you to take some decisions, but it might be as well enrichment against your own information system or against your own threat intel information. Once those logs have been normalized and enriched, you can match them against scenario. And this is already where the community aspect will take place, because we have a hub where people can share and find scenarios that are relevant to their technical stack or to their business needs. Those scenarios are in the form of simple YAML files, and those YAML files, they will be able to describe a scenario to detect an attack. Where things start changing is that we do believe, based on our past experiences, that remediation will really depend from one population to another. For example, if you ask system administrator or people fighting spam, banning IPs might be okay. But if you are speaking to people doing e-commerce, banning a user, which is a potential customer, might be something that is very frightening for them. So we do believe that the remediation should be free to decide on the user hand, and sometimes you want to ban users, sometimes you want to enforce, for example, CAPTCHA or JavaScript challenges, or even sometimes instead of trying to punish the source, you want to protect the asset by, for example, enforcing multi-factor authentication. And last but not least, and this is one of the main innovative points of the solution, is that the information is shared. We do know that security and privacy are two concerns, so the only information that is shared is with the meta information about the attack. Whenever you block an IP, you are going to share the IP that you blocked, the scenario for which you blocked it, and the timestamp at which it arrived. And once this signal has been shared, the system is going to share back with everybody a block list of IPs that are highly susceptible of attacking your own servers, because we have seen them attacking similar technical stacks. So somehow this is where we want to mix the behavior part, which is the local capacity of the open source software we're speaking about, and the reputation, which is done on a more central point of view.
Yeah, we could add here that, given our past in hosting environments and high security hosting environments, we have made this for DevOps, right? We are SecOps, but we made it for DevOps so that it's easily usable in any context you have. It could be home, simply, on your machine to protect yourself, in containers, anywhere you want. It's not supposed to be complicated, neither to install nor to maintain over time. So we took two ideas behind that we wanted to stitch together. You probably know about Filterband, right? This tool has been around for 16 years, and it did actually a great job. It showed us the way in terms of behavior. We want to detect behavior, and we want to block the nefarious behaviors. Now, we wanted to stitch this with another concept, that is IPDB or Spamhaus, or the reputation system. And having both reputation and behavior system would probably cover a lot of glitches and holes that each of those concepts had on their own.
Yes, and so when we say that we really look up to Filterband, we as well inspired of what we felt was a limitation of Filterband, mostly to reflect the changes that happened since then. So first of all, we want to really decouple the detection and the remediation. Nowadays, with modern architectures, it doesn't seem too realistic to want to detect and block at the same place. Your application is partly on-premise. There's some things that are using public clouds, some parts that are even outsourced to other SaaS services. So you really need to be able to detect here but block there. For example, if you have a web application, you might want to block or detect, sorry, on your log servers, but you will want to block the attacker the highest you can, for example, at the CDN level. Then one of the usual friction zone between operation people and security people might be the lack of observability of some security solutions. So you know the famous black box aspect. Here we took care very early to implement strong observability within the software, for example, by instrumenting it very early with Prometheus, which is a kind of technology that speaks more to the admin people. And as we are strongly committed to the community aspect, being by the aspect of them or even the software licenses that we choose, such as MIT, which is very permissive, we really hope at being able to build and bring all together a community that will help each other. And last but not least, while, for example, usual defense software really focus on the IP layer, we do believe that it's less and less true, and it will become less relevant as well with things such as IPv6. So we really want to have a multi-layer aware software, because sometimes instead of punishing origin, you might want to protect the target. So instead of banning an IP that is doing a brute force, you might want to enforce MFA on the users that is being targeted. And all this over a strongly and highly modular system with a modern and simple grammar, we do believe it will allow us to address a lot of the common issues. So, for example, when we speak about the behavioral engine, which is a part that is a local software itself, of course, you can address some of the usual pain or noise that you will see on the internet, such as credential brute forcing and so on. However, a strong grammar will as well allow to address rather complex scenarios and detect more complex attacks as well. So, for example, it can be as well exploitation of web vulnerabilities, vulnerability scans, and so on, not only the simple repeating attacks. Plus, as well, if you take some kind of threats, they are very hard to fight on your very own. For example, if we take credential stuffing is a practice that whenever there's a dump of logins and passwords that are published on the internet, some people are going to try those on every website they can find. It can be an e-commerce website, dating website, email website, whatever. So these attacks are very sporadic and they are very short-lived. So even if you have a team and tool and you start to try to detect them, by the time you detect the attack that is going on and you decide to block it, the attacker will already have finished trying his few hundreds of passwords and will move to the next one. However, if we put into place a crowd aspect, he might be able to attack 1, 2, or 3 users, but then they're all going to automatically report that they have been seeing credential stuffing from this specific IP. And then the information is going to be shared amongst all the participants, and then they can preemptively block this IP, very strongly increasing the cost for the attacker to be able to perform such attack. So this is one example of the kind of scenarios that we do believe the crowdsourced aspect, will help to fight with, along with classical things that a powerful grammar allows to deal with.
Yeah, and regarding this IP reputation system, what we want to have is a huge scale, because the scale plays a major role in the data freshness. As soon as your detection network is big enough, you don't really need to keep any IP on a long term, because if any IP is doing crap at no given moment in time, and then it gets cleaned by the administrator, you should remove it as soon as you can, right? So what we look at is a huge detection, a huge collection network, which will allow us to have a very dynamic database. It's not really about the database itself, it's about really the flexibility and actually the accuracy of the network in real time. So it's highly curated. We'll explain you how, because it's not enough to just explain it's a curated system. You will want to know why. And it allows you to have a tailor-made list for anyone and everyone, so that you don't have to fight yourself with a complicated list system. You can have just your list of IP that is dangerous to your technological footprint. And it's API first, so meaning you would be able to query the API wherever you are, whenever you are, and whatever you are. So say if you use, for example, an IoT device that is pretty dumb and has very few CPU capabilities, meaning it cannot be smart, cannot make any complicated treatment to allow or block an IP inbound. So what you can do there is just like one HTTP query. You know, this is what we told you before. We want to have a universal solution, and the solution should hold in just one HTTP query, super small and super fast. And that any IoT, for example, device can do it. Any device at all can do it. Yep, sorry, that's a glitch. Maybe we'll have a little demo to explain you how it works, right?
Yeah, sure. Thank you. So this is a recorded demo. So here what we are going to see is that we are going to showcase the setup of CrowdSec on a very classical web server. So I'm downloading it, and we are going to use a wizard to go through the installation. The idea of the wizard is to really lower the technical barrier for people to set up. So this is a very classical Linux server, as we'll see, with a web server, MySQL database, and SSH. The wizard here is detecting the various services that are deployed and allows the user to choose the services he wants to monitor and identify the associated log files for each of the services. Once this has been done, the user can choose a list of, sorry.
Yeah, you want to pause it, right? Just click.
Okay. I'm going to, so we are downloading the RIS, and we are going to go through the wizard. The wizard, so he is really here to assist the user in the setup to lower the technical barrier. Thanks. So here it's exposing the user with the various services that are present and finding the associated log files. And then, as we are going to see, it's going to suggest the user with various collections. What we call a collection is a coherent ensemble of configurations that aims at help you to protect a given technical stack. So here, for example, we can see for SSH, it will be brute force protection. While for Nginx, it might be more generic HTTP scenarios, and for MySQL, it's going to be similar things such as brute force protection. From the user point of view, this configuration of the detection part is now over. So while it's installing in the background, you are going to see that it's going to register to the central API so that it can already start to be fed reputation lists from the central system. Deploy some whitelist to avoid binding your private IP's address. And as well, it reminds you, as we explained earlier, that CrowdSec is really in charge of the detection, while the bouncer are in charge of the remediation, and we are going to see later. Sorry.
How do we get to the proper timestamp? Oh, wait, I'll deal with this. Okay. Sorry, just a little glitch.
Yes.
We'll go on with the demonstration, the demo, but we had a new version recorded, and depending on how you share your screen, you sometimes have issues on how to control it. Very sorry about that, but basically where we were.
Yes, so the user, he picked the collection. So now we are seeing the wizard again, but somehow once you are done with the wizard, the setup is over from the user point of view. And so at the end of the setup, it's going to install a whitelist to avoid binding private IP addresses, and it's going to remind you that the CrowdSec part is in charge of the detection, while the bouncer is in part of the remediation. So what we are going to do next is that we are going to simulate some attacks using some classical tools. So here we can see that it's registering to the central API. So it's already starting to be fed with some IPs that might be malevolent based on your current technological stack, as we already told CrowdSec what kind of services we want to monitor. So here we are keeping a look at the, and what we are going to do is that we are going to use Nikto, which is a rather old-fashioned but very typical behavior of a web application reliability scanner. And if we look at the logs, we can see that my IP is getting caught for various attacks, such as coming with a known bad user agent, performing HTTP probing, which is trying to access a lot of files that doesn't exist, trying to crawl non-static files, trying to access sensitive files, or doing path traversal probing and so on. So if we check from CrowdSec point of view, this IP, so which is my IP, should be banned for a few hours because of the default policy. And I can see history of the various alerts that were triggered by the IP or that can be seen on my system. We can as well inspect a specific alert. Here we are going to check, for example, the one about the sensitive files to see which kind of files did the scanner try to access. However, if we go back from the attacker point of view, we can see that my IP is not blocked. I can still access the website. So what we are going to do is that we are going here to showcase the hub. So the hub is just a front end of various Git repositories, and we are going to find a bouncer that is relevant to our technical stack. Here we are going to use the Nginx bouncer, as it will be more speaking for the demo. So we are going to download it on the machine and to be able to install it. At the back, the idea is that all the bouncers are very simple implementation, as writing a bouncer is no more than doing a simple HTTP REST query to a local daemon. And here we are leveraging the power of UI integration within Nginx to provide this kind of feature. And so now if I go back from my attacker point of view, as I install a bouncer, we can see that I am blocked. So what I'm going to do is that for the further steps of the demo, I'm going to unban myself before continuing. So I'm going to unban my IP. And now what we're going to showcase is that, for example, I can, of course, access again my machine. And on my system, I have configured the Linux firewall so that it logs all established or attempted to be established connection. We are going to use this example to showcase again the hub, but this time we are not going to look at the bouncers, but rather at the collections. We are going to use the IP table collection. The IP table collection consists of a parser for the logs generated by IP tables and a scenario to detect port scans. So as you will see, to install a connection on the system, I simply have to pass this command line as CrowdSec manages itself its configuration. I'm going to reload as well the service as indicated. We're going to keep an eye on the logs again. But however, if now I do use, for example, Nmap to perform a port scan on my machine, as I've installed a collection and parsers that will allow to deal with this, we are going to see here my IP being blocked again, but this time for performing a port scan. And again, of course, I am blocked from accessing my web server again. Observability is a very recurrent topic. So here, CrowdSec comes out of the box with the ability to deploy dashboard. We are using the open source software Metabase to do so. Metabase is a bit, for those of you that don't know, like Grafana or such, except that it can work with a very lighter database. Here it's going to work on the default SQLite database that is generated and maintained by CrowdSec. So once the dashboard is deployed, it's going to be able to give us visibility on all the past activities that were detected on the machine and that CrowdSec took action again. At the back, the dashboard deployment is simply firing a Docker container with a Metabase software that is configured automatically to point to the SQL database. So I'm going to access right now to the Metabase setup that we just did. I'm going to connect to it and we'll be able to see what is going on. So of course, here there's not much activity going because we just installed the software and we only simulated a few attacks. However, I will still be able to see my machine, the bouncers that I've installed, and we can see various information about the activity, such as the geolocalization, the history of the attacks, or the machines that push the alerts, along with the various scenarios that has been triggered and information about the source. However, when we speak about the false positive and such, there's one more thing. There's observability. So here we can see the CS-CLI allows you to see as well part of the Prometheus metrics that are exposed by the software, so that the more operation people can see exactly what is going on and what is the software performing, giving you a live view of this. When it speaks about false positive, one of the very common things is, yes, but what would have happened if I had the software in the past? So here what we are going to do is that we are going to run CrowdSec against some old logs from like my logs of 2019. And it's going to really parse the log and analyze them and show us what would have happened if I had CrowdSec at that time. And so here, when we process, it's going to push to the local database again, and we are going to see, and we are seeing here, it's detecting attacks, but that happened in January 2019. And of course, if now we go back, for example, to the metabase and we check not the last months, but the last 2 years, we are going to see the past attacks that are going to appear. So it's a good way for a user either, for example, to generate reporting, to help when you are doing forensics, or simply to test and try your scenarios on past logs to see what would have happened if you had the software enabled at that time. So what cannot really be seen during this demo is that, but all the components of CrowdSec itself, CS-CLI, and the bouncers, they all communicate all together through a REST API, which means that what we did here on a single machine setup, you can as well do it on multiple machines with a machine parsing log and some other machines that are doing bouncers, etc. So simply allowing you to create either simple or rather complicated setup.
Okay, thank you, Thibault. Our goal here is really to make it as simple as possible for DevOps and developers and sysadmin, whomever they want, to install the software and leverage it like in minutes. Like, because literally we install it in minutes. Okay, we know it by heart, but if it takes you 5 minutes, it's kind of worrying because really it's so simple. Soon enough, we'll have Debian packages as well, so you'll be able to install it directly from your usual tools, and that's pretty cool. Just it's taking a bit of time, you know. Like Debian is like a slow-paced distro, very stable, very rock solid, but takes time to get things rolling. So we talked about the hub quickly. The hub is really the place where you find anything that you want to install on your machine, or eventually where also you will want to share your own creations. Say, for example, I'm the CEO of the company, but I'm using the product, and I'm willing to develop some few things. I will do tutorials on it, but I want to develop an ARP watch parser. And I want also to have a few other bouncer rolling and a port knocking system, done. So once it's done, I will upload them to the hub, and the team will review it. So okay, this can go to production. This is safe enough, or this is crap. You should have written this in that way. They will only tell it's crap if it's me. If it's you, they will say, okay, you have progression margins, you know. But yeah, so this is it. Everything you could find and possibly leverage has to be in this one place, because it's cool for the community, you know, to find everything in the same place. It's free, okay? It's free. It's forever free, period. We don't have any monetization plan about this open source software. So you will forever benefit from the software, the behavior software, and as long as you share the signal you're blocking, you're also benefiting as long as you want, and as long as we're around the scene of this reputation system. So both are for free, right? You could disable, if you want, the reputation system, not share anything, but then you would not benefit from the reputation system yourself, which sounds pretty normal. The software runs under an MIT license. It's as free as it can get. You know, we were talking about Debian earlier. Debian is exactly the same license. So, you know, it's really, use it wherever you want, however you want, really. This is the key information here. A bad IP is something that is extremely contextual. It has two contexts up to us: the time and the technological footprint. The time is like, as I told you before, we don't want to keep IPs forever in the database. That doesn't make sense at all. The IPs now are currency like another. It's switching hands on daily and sometimes hourly basis. So what we want to do at maximum is clear out any IPs that hasn't been involved into a hack or a hack attempt for the last 72 hours. The network is powerful and strong enough and fast enough to regenerate and detect any further attempt from that IP, whatever happens. So why keep it forever? Why keep it for 3 months, you know? And the second thing is, so because, you know, back on the time thing, sorry, an IP used to be good, and then it was compromised, and then it's good again. It's clean by its own means. So the lifespan of an IP is very complicated. That's why we don't want to keep it for too long.
Yes, indeed. And when it comes about the context, the thing is that, as Philippe said, temporality of the dangerousness of an IP is something, because IP will go from good to bad and so on. However, the compatibility between a threat and your exposition surface is something that is as important. For example, if I'm hosting an e-commerce website running PHP on a Linux server, and on the other end, I have my grandma that has infected Windows, that is having a worm and that is trying to break into every remote desktop it can find on the internet. First of all, her IP and her machine is not really a threat to my e-commerce website. And second of all, she might even be a very legitimate customer. So here the idea is, rather than redistributing a huge list of IPs where 90% of those are never a threat to you and will never attack you, or even if they do, they won't hurt you. The idea is really to be able to redistribute the lists that are tailor-made. As we know which scenarios you are using, we'll be able to report you specifically IPs that we have seen attacking similar technologies or triggering several similar scenarios on other peers.
Here we will explain you a very crucial part of the software, because, you know, security software, they have one major weakness: is false positives, and this is a curse and a fear for everyone. So what we do here is we curate the signals highly and a lot, so that we're absolutely sure that you never get a false positive, and or that we get poisoned. You know, right? That someone reports your IP where there's no need for that and no reason for that, and then you would be banned for nothing. So we have a consensus chamber, and the way it works is the following: we assign a trust rank to our users. The users that are the older in the system have the higher trust rank. You cannot reach trust rank 1 before being for at least 6 months in the system, right? In the network. If you're a network member with less than this 6 months, you won't be able to partake directly in the consensus. Nevertheless, you'll be listened to. You are trust rank 2 eventually, and we will listen to you, but we will not confirm directly your signals.
And I will add that not only the anciency of the user is taken into account, but as well the consistency of the information that he's pushing. The thing that we can't say poisoning won't be an issue. We can just make poisoning as expensive and as complicated as possible. So what we are doing is that your trust rank is as well based on the kind of information you report, and your trust rank will increase, for example, if you are able to give us some sightings that we are not aware of and that will be confirmed later by users with higher trust ranks.
That's why, for example, in our example, we have a trust rank 1 reporting menace that he found, and a trust rank 2 also reporting a menace. What happens here is, like, since the trust rank 1 has validated the signal by himself, there's no problem. The trust rank 2 will be given a bit of credit for finding it and confirming it as well. So we will trust him a bit more, right? And then say, for example, the trust rank 1 has not reported it, but the trust rank 2 did. We can check the signals against our own honeypot network. And eventually the signal will be validated as well, and the trust rank 2 will get some credit for that. But the honeypot network serves another purpose as well. We can deploy it and expand it based on current menaces or trends. Say, for example, something just got loose yesterday on WordPress, for example. And we want to be sure that we are catching it as soon as possible and as effectively as possible. We can deploy a lot of machines, let's say, I don't know, 1 or 200 on different environments, to be sure that we also can catch those signals as soon as possible and then validate what the network is bringing us as spottings. Next, your trust rank 1 and 2 reported something, and we want to be sure that they are not killing a canary. the canary concept dates back from the mining time. You know, in the coal mines, the miners had canaries with them, and if they would dig into gas place full of gas, the methane would go into the mine and potentially blow it up. And the canaries were there to die first because they couldn't breathe anymore, and they are very allergic to methane, it seems. And the guys could go out before the whole thing can or risk to blow. So here the concept is roughly the same. What we do is we have a crowdsourced list of IPs that should never ever get banned. You know, like say Kaspersky update for antivirus, or Microsoft updates, or Googlebot, or Google DNS, or Gmail, whatever. You know, those things are reliable, very highly reliable. So if you're blacklisting them, first of all, you'll have problem, and most likely your scenario is twitchy. So we will not consider you poisoning us, but we'll say, okay, maybe the scenario you're using is a bit twitchy, and we will not consider this point.
Yes, and last but not least, I think that as the canaries, as for the source code, the idea here is really to make something that is transparent. So this is part of a GitHub repository as well, so that legitimate actors can declare themselves and people can add. For example, very early, we're working with people from the e-commerce background. They are very specific kind of IPs or actors that they will never ever want to see banned on their system.
Like the PSP.
Yeah, or PSP or SEO mechanisms.
Yeah. So the next one is, you know, we are not allowed to say artificial intelligence, because I saw some VCs and they were like, okay, guys, you're doing cybersecurity, you're doing SaaS, you know, and just put AI and blockchain, and it's a bingo bullshit. So we won't put any money in your company if you put AI, right? So it's not AI, right? It's machine learning. It's very, very different. So what we do is we are digging in our logs, in our honeypot logs, and it allows us to find, say, low noise signals, right? Because the system itself tends to be a low frequency pass filter, if you're familiar with electronic. So what we want to do, though, is still see the very low noise signal, because they're interesting to us. Say, for example, a complicated pattern could be IP A is just connecting to your port 80 to check if you have a web server running. And IP B is then checking for vulnerability, and IPC is exploiting it, right? And they come at different times from different places. So how would you know that those three are related if they are really related? Well, with a frequency analysis in the logs, we could see that IP-A just comes usually 15 minutes right before IP-B, and IP-B just 15 minutes before IP-C, for example. And that would be a very low noise signal that we could not detect directly through our network, but that this non-AI system would be able to catch in the logs. And that's a very, very basic example of what we're trying to achieve with it. But, you know, so once you pass all those barriers, somehow you end up in the IP reputation database. Congratulations, you made it to the core system and the IP is blocked. We see here that it would cost a tremendous lot of time and money to rig the signal system, and a lot of patience as well. And if you're feeding us with proper signals for months before turning rogue, thank you. You helped us for months. And as soon as you make a false report, your trust rank will fall quite immediately. So we're benefiting even eventually from this. I don't know if we have time for this one. Let's more talk about this one.
Sure. So one of the early concerns that a lot of users had with the software is what kind of information are you sharing? What about privacy and so on? So what we are strongly committed to is that the only information that is shared from your system to our system, we are never going to share logs. The only thing that is going to be shared is that if you are using CrowdSec and you use a default setup, which means that you push information to the API and you get blocklist from the API, whenever you are deciding to ban an IP automatically, you are going to push to us the IP that you banned, the scenario that you used, that the IP triggered, and the timestamp. And if your scenario is something custom or you modified one of our scenario, we are not going to report it because we wouldn't know anyway how to exploit this information.
And you know, we have a commitment toward this open source community, right? So we want people to eat properly. They are all experts, and you know, they can earn a lot of money on the market, our guys. So we want them to be paid properly. So we are not. We have to monetize something. Sorry about this for the very purist within the ranks, you know, with the bearded and stuff. But it's just the way the world works. So we will monetize something, but in the fairest way you can think about. we will never ever screw up the community. Everything will stay for free for the community. What we monetize though is access to the API database for the companies that don't want to share anything, first of all, and also fleet features that allows those company to deploy and configure and maintain a large number of CrowdSec instances from a central point that is for convenience. That's pretty much it. With IP repetition at scale, we can tackle a lot of fraud. Trust me, really a lot of them. Every pass you see here is super easy, maybe not, but really easy to tackle with the system.
Yes.
Maybe Thibault, you want to talk quickly because we are 4 minutes or 3 minutes left?
Yes.
About sure. 2 examples?
Sure. So I'm going to focus on the first one that I think will be the most relevant. It's one of our early users. They were operating some anti-DDoS protection system, and they were previously using some homegrown software with Filterband on top of it. So they were dealing with the usual, HTTP DDoS that you can see quite often, with a botnet of around 7,000 IPs or machines that are hammering one website. And he was able to quickly set up a CrowdSec and create a very custom scenario to deal with it. And he was able to tackle the whole botnet within less than a minute. I think we do even have a blog post somewhere about it.
Yeah, sure, on the website.
So this, and another example would be more like e-commerce related. For those of you that are in this field, it's a user that was having to deal with credit card stuffing. So it's someone that is getting a bunch of credit card and using a targeted e-commerce website to validate or not those. It's very expensive for him as he's having to deal with bank fees. So here, what was interesting for him is that he created a CrowdSec scenario that is dealing directly with his applicative logs, because this is the only place where he could detect that someone was actually doing some credential stuffing. And he was acting at the applicative level to block them, because again, some population, for example, if you are dealing with a massive botnet, banning IPs is fine. If you are dealing with a potential suspicious activity, but within a payment tunnel, you are a lot more reticent to banning an IP address because it might be a potential customer.
Yep, absolutely. Well, we see keep on that one for timing reasons. Remember, it's like IPv6 is compatible. You get observability right down the road. It's stateless and decoupled. It's made for modern architecture. You can replay logs with new scenarios to see if there are anything is going wrong. It's multi-state detection, multi-layer responses. You can do live API query or local cache query to avoid breaking anything. That's pretty much it. We want to be the ways of firewalls. That's pretty much it. If you think about it, we are building in a set that is real-time, powered by users, and made for users. And that's what we intend to do within the next years. So if you have any question, I guess the time is right. I don't know if we can take questions.
Yeah, I'm looking at them. There's no question for a moment.
Oh, okay, right. Well, we can say is like we have a new ambassador for Canada, and we hope that maybe some other people will want to join with us. He's called Cyril, and he's been in info security for a while. He's working for air traffic system, and planes and very high and complicated security systems. And he wanted to join the round and help us develop CrowdSec reputation and communities around the world. And he's joining for Canada. So if you have any question for him, we'll create his email. On the right side, you see an email. We'll create it right after the conference. I just had to toss one email in the slides quickly. It will be activated within the next hour. But he's a new ambassador for Canada. Don't hesitate if you feel you can help the community. We'd be really delighted to hear about you either on our Gitter or on our discourse forum.
Yeah, talking about the Discord, we do have the Access Discord where there's a place for question and answer. So if people have questions, they can ask you there. What are your Discord ID so they can write to you directly on that
Sure. Our names are Brixor on Discord, right? Buixor. This is the CTO. This is Thibault who talked. And mine is Cameo, Kameo, and I'm the CEO of the company. So you can reach us both in the Discord forum, and we'll be glad to answer.
Okay, thanks.
Thank you.
Thank you very much. Bye.